thing.
Okay. You want to walk through glycolysis?
Sure.
Okay. Go for that.
Yeah.
So we got glycolysis. Glycolysis takes place where?
In the cytosol or the
Cytosol, right?
Yeah.
So we just entered the cell here. And how many carbons is glucose?
It's 6.
6, right?
Mm-hmm.
And so the first thing that we want to do is we want to trap it inside the cell.
Okay. What you said that earlier, you said that we need to add a phosphate to make it too large to come out.
Exactly. So how do we add that phosphate? Where do we get it from?
Is it ADP and ATP, or is it? I don't know what.
Yeah, it's from ATP.
It's from ATP.
So
Okay.
ATP goes, oh, glucose, it looks like you need a phosphate if you want to stay. So I'm going to give you one. And I'm willing to become ADP for you.
Okay.
So we attach the phosphate. Now it's stuck in the cell, it's trapped, can't get out.
Okay.
So number 2, this is the decision. You remember what the decision is?
Well, it's whether to go through glycolysis or whether to attach to other glucose.
Yeah, become glycogen.
Become glycogen and go stored in the, where's it stored again?
Liver.
In the liver. Okay.
Yeah.
Cool.
And so another ATP goes by and says, you know what, we need you. I'm willing to become ADP for you too. And so now we have this molecule known as fructose, which is monosaccharide, right? Found in fruits.
So it's fructose. Okay. I don't have that on here, but I like that. This is fructose. I'm gonna put that. Just for future. It'll help to have a better understanding of this. I don't know how many people in our classes realize, we have a comprehensive, by the way.
Yeah, that's
We're already
true.
doing this stuff here.
Makes you worry about some people and
Yeah.
not studying as hard for all the tests.
Yeah, I don't know. It seems like a lot of people did well in this test, and a lot of people didn't. That's probably normal.
Yeah.
I happen to do well. I studied a lot, but it still didn't make the test. This test was still challenging though.
Oh yeah.
Gosh.
They're always pretty. I finally took one this semester where I was like, oh, that's kind of an easy net and phys test.
Really?
It was still tough, but compared to all the other ones, I was like, that wasn't nearly.
Does he have you take them? Are you able to take the ones we take?
I took yours last semester, so I'm a 265 student this semester.
Okay.
So,
Cool.
yeah, I took those. Those ones, the first like 2 or 3 were just long and
Yeah.
make you think forever.
I missed some silly questions, man. I looked back through it and I thought, what?
Same here.
Just a basic
Oh, I
one.
know
It was
that.
about a protein channel.
Oh, really?
It said the one about the slide,
Uh-huh.
and it says it's selective on what it chooses. I think I put, was it transport protein or something? It was just a protein channel, right?
Yeah, probably.
But I was just thinking about, I don't know what I was thinking.
It's funny. Your brain just does funky things.
That is the
during
simplest
testing
question you
center.
could freaking do. Yeah, I didn't give myself enough time. I kind of rushed myself. Anyway, well, I ended up getting a 98, so how can I complain?
That's way good. Did you have the highest?
No, well, no.
Someone get 100 or?
Somebody got a 94, but it was curved, of course.
Oh, is it? Okay.
Yeah, so that's what I got at with the curve, but I should have been able to actually get close to that, just with without the curve, but
Right.
that would be sweet, because it would take you up over 100.
So you have like 108.
Oh, I need that right now. I'm sitting right in between an A and an A minus because of the in-class quizzes.
Oh, really?
Yeah, sometimes I don't prepare well for those, and I bomb one, and I mean, they're basic in a sense too, so he drops 2 of them
Oh, really?
at the end, so that'll help me a little bit, take my average up and boost my grade, but anyway, so this is glycolysis.
So, glycolysis, we just made fructose, right?
Yep.
So an enzyme comes by. Usually they say you don't need to know the name of the enzyme. And what the enzyme does is it breaks things up, right?
Yeah.
And so it breaks up fructose. So now we have 1 phosphate with the 3 carbons,
Mm-hmm.
and then another one. And so now we have like 2 substrates, right?
Mm-hmm.
Of fructose. So So it's just divided. Well, we have other phosphates floating around in here. And they want to combine, but they can't because hydrogens are in the way, right?
Mm-hmm.
And so what we
How do I know that they're in the way? What do I have to know the?
No, I don't know if it's going to be a huge thing on the test, but if you were to actually draw it out,
If I could think about that.
or it's like, I don't know how they do it. I don't
Okay.
know all the chemistry behind it, but
Okay,
pretty much, I'm just drawing a fake version of it.
that's fine.
The hydrogen's here, the phosphate wants attached there,
Mm-hmm.
but it can't unless the hydrogen leaves, and then the phosphate can go there.
Okay.
So usually they'll have charts or something that they give you.
Yeah.
If you look closely at it, you can see how the hydrogen's in the way, but
Okay.
it's a little tricky. So NAD comes by,
Mm-hmm.
picks up how many protons, how many electrons?
2 electrons and 1 proton.
One proton, right? So it
Mhm.
becomes NADH, and then that phosphate's now able to attach.
Yeah, is that an important thing to know about the electrons, protons?
It may be a test question. I know that he uses it in the, my teacher used it in the sample questions.
Okay. I'll just put that.
But you'll want to know that it drops off the 2 electrons and the proton at the electron transport chain,
Okay.
right?
Yep.
So I think that might be the,
So NADH picks up those and becomes and that's how it becomes. It's inputted and then it picks up those and becomes NADH.
yes, yeah.
I mean, that really, I don't know. I like to know that. I mean, we have it here, you know, where the input output kind of the table there.
Oh yeah,
Okay, I put NADH in whatever I do with it, and then it becomes NADH. But if I think about that, that connects me a little bit more when I get to the electron transport.
yeah.
Personally, don't you
Yeah,
think?
now you know the 2 electrons are transferred from there.
Yeah, and
Rather than
that's
just-
how the hydrogen's transferred, right?
Yep,
The NADH attaches the hydrogen and that takes it to the chain
yep,
and drops it off.
yeah.
That's important. Okay, cool.
Okay, so now we have ADP combined. And what's ADP saying? It's saying, oh, I gave you a phosphate earlier. I kind of want it back.
Yeah.
Kind of like an Indian,
Mm-hmm.
what do they call it? Indian trader or something?
Mm-hmm.
So now it becomes ATP and it takes a phosphate off of there. Then we have another ADP combined and said, well, if you gave him one, I want one too. So now we produce ATP, ATP, and ADH. And we did the same thing on that side as it's going down.
Which step are you in? Are you in a certain step? Are you in the NADH production?
So we made NADH here. And then number 6, this is called substrate level phosphorylation. I'm trying to figure out how to spell this word still. I should really just look it up. And so when we're producing this ATP here, this is the substrate level phosphorylation. Because it's a substrate of fructose, and phosphorylation means you're adding phosphates. So we're adding phosphates to ADP to make ATP. Does that make sense? Yeah.
So how many, so it's a triphosphate, it already has, okay, so ATP has 3 phosphates?
3 phosphates. So yeah, you'll have adenosine,
Okay,
a phosphate, and a phosphate.
okay,
And then when we add another phosphate, it's like trying to push something into, it's like trying to make a spring. I'm trying to think of a way to explain it. It's like adding another piece to a spring, but trying to make it the same size, so you have to push it down.
okay.
So once it's released,
It has energy,
it has
basically.
energy.
Ah, that's a good analogy, I like that.
So there's ATP, now we've got it. So whenever we release ATP, we're going to be releasing energy with it. Whereas ADP is kind of like a spring that's unloaded, really.
Okay. I kind of wondered how it worked when it was, I know it was the bond as far as the myosin heads and all that.
Yeah, certain bonds, when they're broken, they release more energy than others.
Mm-hmm.
ATP is an efficient one. You also learn about a carbon-hydrogen bond,
Mm-hmm.
which is actually I believe that's what's being broken when we're receiving the hydrogens to the NAD. So a lot of energy is released right there. So when you're doing really explosive movements,
Mm-hmm.
your body heats up really quick
Oh yeah.
because it's going through glycolysis and those bonds are being broken from those sugars.
Hmm.
And it happens.
That's pretty cool. That's pretty cool to think about. You
Yeah.
think about our body produces heat, but there's a reason behind it. It's because there's processes going on that create it.
This big.
Yeah. Millions of them, right?
Yeah.
How fast do you think this takes place? I mean, we can't even.
Oh, we have millions of these.
We talked about muscle
a second.
contraction too. We break it down into this small. Oh well, this step happens, and that stuff's just going. You know, you can't even really
Yeah.
fathom it.
And an action potential travels
1
250
millisecond.
miles per hour.
Does it?
Yeah, which
Wow.
is 400 kilometers an hour, which
That's-
is just insanely fast.
Who needs kilometers?
Right.
No, I'm just kidding.
It's insane how fast it works.
Yeah.
The body's just so efficient at it.
Yeah.
So once these ATPs have been produced on this side as well, we're now left with our pyruvate.
Okay.
And so this brings us to our last step of glycolysis, which is decision number 2. What do you think that decision is?
The decision from here is to decide whether it's going to the. Well, you have the citric. Is it the citric acid cycle
Yep. For the Krebs cycle, yeah.
or the Krebs cycle? Okay. So what's the decision it needs to make? It's got to. It depends on whether it's aerobic or anaerobic, right? So whether it has oxygen or not.
Yep.
Okay, if it does have oxygen, it's not going to be able to perform glycolysis. If it has oxygen, right?
Yeah, so if it has oxygen,
That means it's going to become lactic acid.
it says, hey, as long as the oxygen's over there, I'm willing to go through a lot to be with oxygen. So I'll go through Krebs cycle, electron transport chain, I'll do all of that, as long as there's oxygen.
Okay.
But if there's no
If
oxygen,
there's no oxygen, that's what it does. Okay.
I'm going to produce
Lactic acid,
right?
Yeah.
And so the way that it produces lactic acid is, remember how we made NADH over here? What does NADH do? It's a taxi cab, right?
Mm-hmm.
So all it does is it takes a hydrogen, drops it off, goes back, picks up another one. So NADH comes down here, and it drops off the proton and the 2 electrons.
Mm-hmm.
And so now it's attached to this, and it becomes lactic acid. So our NADH just became NAD plus again,
Mm-hmm.
and then it goes back up to there,
Okay.
and just keeps cycling through. So if you don't have NAD, you can't do glycolysis. Everything's gonna stop right there.
All right. Does NAD have a formation? Does it have a? Is it any of these configurations here? The carbons with the phosphates, or is NADH? I mean,
It
do
would
we
have that. I don't know what it is.
Okay,
but
I
yeah.
didn't. Okay, I was just trying to figure out if we had any. Am I going to look at something and say, "Oh, that's NADH"? We just know it's what it does in the
Yeah.
process. Okay.
Yeah.
So
For
anytime-
whatever reason, hydrogen leaks it a lot, though.
Okay. So you add NADH whenever you need to. What is it that breaks the carbons off?
At what point?
What is it that breaks them off? I have it here, but those. Yeah, that's what you do when you need to break one off, especially for the cycle, for the citric acid cycle.
They're usually closely related. They're around there, so they happen almost the same time at that point.
Do they?
But it won't break the carbon off necessarily.
It
But
won't,
usually,
yeah?
like when the CO2 is getting broken off, and then ADH is getting broken off. But these
Okay.
carbons are broken right here just through an enzyme,
Yeah.
not through NADH, even though it's followed closely afterwards.
Okay.
So
Gotcha.